Okay, so we've talked about shifts and centers, and we've talked about how you have to give evidence, and then you have to talk about what this means back in the sample and in the population around shifts and centers. So again, what this generally means is the box of the males is shifted slightly right, and the median is slightly right of the females, which would suggest that in my sample the males' blood pressure is slightly higher on average than females. But there's not much difference, and there's not much shift either in the boxes. So this might suggest that back in the population, there's not much difference between these two groups. So every time you talk about this and you give your evidence and your numbers and your values, you then have to say what this means back in the sample and back in the population. Now, if we look at spread and overlap, spread is always about the interquartile range. And in this case, for males, you find the interquartile range by doing the upper quartile minus the lower quartile, and you get a calculation. In this case, it's 7.7 with its units, mmHgs. Then we do the female interquartile range, 8.7. So the fact that the males is a little bit smaller means there's less spread and less variability in its middle 50%. So we say that the interquartile range for the sample of males' systolic blood pressure is smaller in comparison to the sample female. This could mean that again in their sample and back in the population there's less variability for males' systolic blood pressure as compared to the females. So spread is just about variability, so you use that word. So the interquartile range tells us that in the sample males' middle 50% is more variable, or is that should say less variable. That this might suggest that back in the population there's also less variability in males' blood pressure, systolic blood pressure. So that's what it means. Now we talk about the overlap, and we can see that there is a ton of overlap between these. The males' middle 50% is almost entirely inside the females' middle 50%. So we say that there is much overlap of the interquartile ranges between sample males and the female sample. This could mean that the population, there's not much difference between males and females, as the two samples are very, very similar. So that's what you say again about back in the population, what just suggests, and our two samples are very, very similar to each other. And also, although I haven't done it here, you should give some evidence around that overlap. Why would you say there's a lot of overlap? Well, that's because the interquartile ranges, the lower quartiles and the upper quartiles are very, very similar to each other. There's a lot of overlap of those interquartile ranges. So if you've given evidence for, you've got to give some evidence here. There's no numbers, and so you should probably use where the lower quartiles are in relation to each other versus the upper quartiles. And you can see there's not much difference between those two things. So a little bit of evidence would go a long way in helping with that explanation. We're also then going to talk about shape and symmetry. So shape's a bit arbitrary. You kind of have to look at the dot plot to get a shape, and sometimes it's useful to sort of do a kind of a little bit of a flowy thing to see what the shape of things are, and they're fairly bell-shaped. You've got bimodal here, you've got two modes, reasonably symmetrical, and that sort of is indicated because the medians are both in the middle. And so we say that by looking at the dot plots, the sample male dots are bell-shaped. This is reflected in the box plot, so there is symmetry. This could mean that the population, there's a symmetrical distribution and so on. So you just kind of try to talk a little bit about whether there's any skewedness, because if there's skewed data, you need to talk about that. If it's fairly symmetrical and bell-shaped, you talk about that, and you do it again in relation to each other. What's the comparison in shape? It's less important that you make an inference back to the population around shape. It's very important that you give evidence and inference back to population and sample with the other three categories: shift, centers, spread, overlap, and so on. And then we'll talk about unusual. If there's anything unusual, really no unusual data in this, nothing unusual. So you basically say that there is no outstanding unusual features such as extreme outliers or anything in this data. They talk about one being bimodal and so on, and where those two modes are, and that's about it.